Welcome, my name is Nachiketa. I'm one of the tutors at Alpine Prep Academy, specializing in IBHL chemistry, math AHL, and sports science HL and SL. Today I'm going to be talking to you a little bit about sports science, more specifically, cardiovascular drift. All right, so you will learn about cardiovascular drift as it's part of the ventilatory system and circulatory system. It is a phenomenon that occurs because as an athlete during exercise, during prolonged exercise, your cardiac output must remain constant for a steady state exercise or a submaximal exercise. All right, so you know the equation to solve for cardiac output. Cardiac output is denoted by Q. So Q is equal to your heart rate, which is your beats per minute, times your stroke volume. Okay, so beats per minute and stroke volume is defined as the volume of blood pumped by the heart every beat, and it's usually via the left ventricle. Okay. And obviously cardiac output is defined as the volume of blood pumped every minute throughout the body per minute. Okay, so how does cardiovascular drift occur? Cardiovascular drift occurs because if one of these variables, heart rate or stroke volume, decreases, to maintain the same cardiac output, one will have to increase. So in this case, cardiovascular drift always or usually occurs because during submaximal exercise, you start sweating, and perspiration reduces the plasma content within the blood, making the blood more viscous. So blood more viscous due to dehydration. Okay, what does this mean? When the blood becomes more viscous, the blood volume decreases and essentially your stroke volume decreases. So SV decreases. And since we want to maintain the same level of cardiac output, therefore, heart rate must compensate and increase. Okay? One more reason is also the heart rate must increase is due to thermoregulation, as you go through vasodilation and your blood vessels get closer to the skin, reducing the blood supply to your muscles. Okay, so let's look at this. So now from what I've told you, let's try this question. Outline cardiovascular drift and methods of reducing it. Outline, you need to remember your keywords. Outline just means tell me what happens. Okay, you don't need to give reasoning, you just need to tell the method start to finish, and then obviously show methods of reducing it, because this is 5 marks. Okay, so in this question, because it's 5 marks, the mark scheme says it's maximum 4 for the phenomenon, for the outlining, and 2 for the prevention methods. Okay, so let's start. So, as I said before, it occurs during submaximal exercise. This is 1 mark. So, submax exercise. Okay? 2, it's due to the reduction in blood volume due to sweating. So reduction in blood volume due to sweating makes the blood more viscous. That's your second mark. The third mark is going to be for, as I said before, the reduction in blood volume. So reduced blood vol leads to a reduction in your stroke volume. Okay? And therefore, due to the reduction in stroke volume, heart rate has to increase to maintain cardiac output. Okay? One more thing is that you can add this, but obviously now we have 4 marks, that's more than enough. But if you want the 5th, if you want to be thorough about it, you say vasodilation also causes a reduction in blood flow to working muscles, because the blood is you're trying to cool off, and the blood vessels are going closer to the skin. So vasodilation, more blood to skin, less blood to muscles. Now on to the prevention. Prevention, it's quite simple, honestly, and it just takes a little bit of common sense. Firstly, why not maintain hydration? So maintain hydration, especially because if you're doing submaximal exercise, you can kind of still multitask. You don't really have to just focus on one thing. So this reduces blood viscosity. Okay? Even stuff like decreasing your exercise intensity, that decreases your cardiac output, hence you don't have to, your heart rate won't go so high. Increase CO by decreasing intensity. All right. And lastly, these two go together. 8 plus 9. Exercising in cooler parts of the day. See, this is what I mean. It's logic, it's common sense, but you have to think about stuff like this. Exercising in cooler parts of the day during exercise during cooler times to reduce sweating, and also wear breathable clothing. You're not going to be running a marathon in your jeans, are you? So there you go. These are all the points, and this is cardiovascular drift.